Hello, this is the video for Thursday, April 2nd. We're going to do some more examples of performing hypothesis tests to analyze one proportion examples. So basically, I'm going to run through 4 quick examples today. First example, there's a fungus attacking some kind of plant, and we happen to know that plants that catch this fungus have a 23% survival rate from a fungus. That's their survival rate if you don't do anything. You just sort of like let the plants go, fight it off as best as they can, and see what happens if no treatment. So we want to try a new treatment. So we want to try out a new treatment. And we don't know if this treatment's going to make things better or worse. I mean, we hope that it's going to make things better. That's our theory, but you can never really predict what's going to happen. So it's possible, the cure, like that the treatment will actually makes things worse. And if that's the case, we want to know that too. So better or worse, we don't know. We are going to run an experiment, test this treatment on a bunch of plants and see what the survival rate is after they have the treatment. Before we see the results of the experiment, we're supposed to pick our significance level, the percentage, which is going to be our line for small enough that we consider it strong evidence that our null hypothesis is false. And we also are supposed to pick our null and alternative hypothesis before we actually collect data. That way the results of the experiment, like we don't sort of like fit our hypotheses to the experiment. You're supposed to say, here's something I want to test, and then you test it. You don't like run experiments and then base your results on what happened. That's not the way these things are supposed to work. That's bad science. So we're going to test at the 1% significance level. So when I say test at 1%, I mean we're going to use 1%, 0.01 as our significance level. If our p-value comes out smaller than that, we will say that our results are statistically significant and we have evidence that the null hypothesis is false. We have to pick our null hypothesis. That is the 23% that happens when there's nothing. We want to know if the treatment is making a difference. If it doesn't make a difference, it's still going to be 23%. So P is equal to 0.23. That means that the treatment is basically doing nothing. It's the same as if we hadn't treated it at all. And our alternative hypothesis is going to be that P is not equal to 0.23. The default alternative hypothesis is always not equals. And that means that possibly more than 23% survive, less than 23% survive, we don't know. But our alternative hypothesis is that it's not going to be 23% anymore. Okay, so then you go and run the experiment. So we test 80 plants, and out of those 80, 30 survive. Okay, so we're testing the treatment on 80 plants and 30 survive. So 30 out of 80, that sounds like it's a fraction bigger than 23%. 23% is 23 out of 100. So it looks like the treatment helped, but it is always possible we got lucky. Did it help enough that 23% is now unreasonable? Is there like a less than 1% chance, because that's our significance level, that this result could happen if the treatment was doing nothing? Okay, so let's run our hypothesis test through Minitab. So we'll flip over to Minitab. And how do we run the hypothesis test? We go stat basic statistics, one proportion. I have the summarized data. Eventually we'll have examples where we actually have the data in the table, but not for a while. It was 30 out of 80 that survived. The event we're looking for, which is the plants recover, there was 30 of those. The total number of trials was 80. We're going to perform a hypothesis test. The hypothesized proportion, that's our null hypothesis number, so that was 0.23. Go into the options. Confidence level, that's for confidence intervals, which we aren't doing right now. My alternative hypothesis has a not equals that matches what I wanted to do. And choosing between exact and normal approximation, we are using exact. Okay, so I think everything's all set up. So we hit OK and see what we get. All right, so what we're really looking for here is this p-value. Let me get some more decimal places. So it looks like our p-value is 0.0048. Okay, and that's really all we really need from all of this output. So I'm going to flip back over to Word. Get a p-value of 0.0048, and that is less than 1%. Okay, so a very small p-value means that you have a statistically significant result. You have strong evidence that the null hypothesis is not true. There's less than a 1% chance that this test could have happened if the survival rate was still 0.23 with the new treatment like it was without the treatment. So so we're going to sort of like summarize our conclusion by saying we have strong evidence that the survival rate with treatment is not 23%. Now, our survival rate turned out to be higher. It was like 37%, but that's sort of like a side conclusion. We were directly testing, is it not equals? Is it something other than 23%? And we found strong evidence that it was indeed probably something other than 23%. Okay, so note it could still be 23%. There's still like a 0.5% chance that this experiment could happen, and that's not nothing. So maybe it was just a weird batch where there were 30 plants that were good at surviving. But we drew our line, we said 1% was our line, and the p-value came out under that line. So we have strong evidence that the survival rate with treatment is not 23%. Okay, so the treatment's doing something, and looking at the results of the experiment, it looks like it's helping, not hurting. All right, so that's it for this example. We'll put each example in its own video.